Hello everyone. Today I will be talking about how we can test a single variance. Let's say in a population we have data set and then we are interested to know the variation in that population for a specified variable. Let's say in British Columbia we are interested about the wages in working group. Then we would say that how much variation we have. Or let's say we want to compare two countries, the air pollution, and then how much variation we have within the data set. If we want to do that, then we have to compare the variability in those two countries' weather conditions. So that's what I would show you in this video. I would like to walk you through how we can perform some hypothesis and how we can actually create some hypothesis so that we can test whether the variability in a single population is some value that we actually assumed or we actually came to know through some study. And then maybe we would have two population, then we would try to see which variability in which group would be maybe one would be higher than another one, or maybe they are the same. That's what we would like to perform, the kinds of test we would like to do. So first of all, I'm going to talk about how we can test one variance. Let's say in a data set, the data set we got a sample data, and in the sample data we have 25 sample. That means sample size is 25, and then we say that the variability in the population, let's say we would like to test the variability is 0.0024. This is small, but then again it's actually we have some variability information of the population, and that's what we would like to test. Is it going to be true or not? So at first we wrote down the variability is 0.0025, or sometimes you will see that people are testing whether there is no variability. That means everything is exactly the same, all the variable value, then it will be equal to 0. So we say that we have some variability, and then the alternative we want to test is that whether it's actually more than. That means over here we are going to perform one-sided test. So when we talk about variability, what's the test we have to perform? What would be the test testing? What would be the distribution? So you know from previous sampling distribution that the variance actually follows chi-square distribution. So in the chi-square distribution, it's not like normal distribution. In normal distribution, it's actually bell-shaped, and then it's on both sides is actually the structure, the shapes, everything is same. But in the chi-square distribution, it's not the same. It's actually right-sided. Let me draw that for you. So let me draw. So in the chi-square distribution, you will see that it's actually right-sided, and then somewhere here we would have the population variance. So that's the distribution of chi-square. It should be like that. It's narrowed down, so you can see in the textbook it's actually drawn perfectly, but over here I didn't draw it perfectly. Anyway, so you can see that it's not bell-shaped, so that means it's actually skewed in one side. So we have to be careful about when we are actually picking the critical region. So you can see that at first we wrote down the hypothesis, and then after writing the hypothesis, then the question is the level of significance. So level of significance, it says that if it's not mentioned in your question, then you can assume 0.05. Okay. And then in the chi-square distribution, what's the critical region? So at first you need to find the degrees of freedom. So degrees of freedom here is sample size -1, sample size is 25, that means the degrees of freedom is 24. So we have to go to the chi-square table, and then we have to find for the 24 degrees of freedom and level of significance 0.05, what is the critical region we have to find. So in the critical region, it depends on what's in the alternative hypothesis. That means it's actually in the right side over here. So that means we need to find out what would be the value, the critical value, the cutoff point, and then the critical region is somewhere here. Okay, so what's the tabulated value, the critical value? You have to go back to the chi-square table, and then you have to find it there. Let me open the chi-square table. So here is the chi-square distribution, and then the critical values we have. But you can see that in the chi-square table, we have the shaded area is on the below, just like the T distribution. Okay, so what we need the, let me draw here, we drawn here. So we need the upper region, right? But in the table, you can see that it's only giving you lower region. So what we can do, so we can think of, since this is 0.05, the other region, that means this point, if we start from the beginning and then up to here, so that means the probability would be 0.95. Since we have the lower region, we need to think of what would be the area under the curve for that probability. That means we can find 0.95. So for 0.95, it's here, you can see that. And then the 24 degrees of freedom, you need to look for 4.95. 4.95, the degrees of freedom 24, the value is 36.42. Okay, so if I go back, so I can see that 36.42 is already mentioned here, and now you need to compare with the test statistics value. So test statistics is simple. All you need to do is to use sample size -1 multiplied by the in your sample, what would be the variance, divided by what's the variance in your null hypothesis. Okay. So if you add them, then you can find the test statistic value. So the test statistic value is given here. The standard deviation we know, but we need the variance, so we actually square them. Then we found that the chi-square test statistic value is 61.44. So you can see that the value we found from the critical table is 36.42, but from the test statistic we found it is 61.44. That means it's way above the critical value. That means it's actually falling into the rejection region. Okay, so that's why we say that the variability of our product exceeds the quality control standard. That means it's actually null hypothesis is rejected. That means we go for the alternative, and then we said what we found in our study, in our hypothesis testing. Okay, if it is two-sided, then you have to use or the other side, then you have to use the other region. Since we have the critical region or the rejection region is on the right side, that's why we actually rejected it. Okay, now I want to talk about test concerning two variances. So in case of two variances, that means we have two populations or two groups, and then we are trying to compare the variances of one variable in both groups. Okay? So let's say we have two population. From the population, we collected some samples, and then you can see that the one group we collected 25 samples, and then another group 16 samples, and then we have the mean, we have the standard deviation, we have the variances for the sample. In the hypothesis, we can write it in many different ways. So let's say we are interested to compare them. When we are comparing them, we can say that both are same, or we can take it into other side, and then it's the same thing. Ratio of them is 1. So we basically try to see that what's the ratio of them. If the ratio of them is 1, that means they are same. If the ratio of them are not equal to 1, that means one it could be greater than other one, and then we can test that maybe one is greater than other one or one is less than other one. Then it's a two-sided test, and then we can perform a test. But then again, for the single variance we use chi-square, but for ratio we have to use the F test. You saw that for proportion we use Z, but this is a ratio, this is not a proportion. So for proportion for the ratio, that means two groups variances whenever we are comparing them, and then we have the ratio, we have to go for F test. So let me actually draw the distribution for F test. It's similar to, the structure is similar to chi-square, but then again the distribution, critical values, the distribution is different. So it's like that. So you will see the proper distribution is given in the textbook. So this is the lower region, this is the upper region. If we have the two-sided test, that means critical region will be somewhere here, critical region will be somewhere here, and in the middle we have the acceptance region. Okay. And then what we need to find is that at first we need to define what's the level of significance. Level of significance is 0.1. That means in the middle we have 0.9. Since the level of significance is 0.1, 0.90. Okay. And then the level of significance is divided into two areas, but it's not exactly the same in both areas. We cannot say that alpha by 2. It's not possible. This area is 1 minus alpha, but these two areas, if we join them, if we add them, it will be 0.1. Okay. So over here we are trying to see that what's the critical value in here. Let me actually use another color. So critical value over here and then over here. So in these 2 points we need to find what's the critical value, so that we can actually compare with the statistic value. So for the critical value, you need to think about the, let's say in the sample, what was the sample size, what was the n1, and then degrees of freedom will be v1, what is the degrees of freedom, and then v2 degrees of freedom in the second group for n2. That's what we need to find out. Okay, so in the data set you can see that the sample size is 25 and 16, so the degrees of freedom will be 24 and 15. So in the upper region we will use the 24, 15 and level of significance by 2. So that's what we will see, that in our upper region the critical value would be 2.29. So we need to find out what would be the degrees of freedom. I will show you in the F table. And then for the lower value, what we need to do is that I showed you in the other video in the previous lesson that we need to find the reciprocal. But whenever we are trying to find the reciprocal, then you will see that you have to change them. Denominator will be numerator, numerator will be denominator. That means you can see that 15, 24, previously it was 24, 15. And then we have to change the level of significance. Previously it was 1 minus alpha by 2. That means 1 minus 0.05. And then now it is only 0.05. So that you have to find the lower value using this formula. Okay. So I would like to show you how we can find them in the F table. Let's find in the F table, let's at first find the 24, 15 is 2 degrees of freedom. 24 is numerator, 15 is the denominator, and level of significance by 2. That means 0.1 by 2 is 0.05. That's what we would like to find at first. So you can see that I open the F table. In the table, I need to find in the numerator, I need to use the 24 V1 and then V2 25 in the denominator. And then if I look at that, then you can see that for 0.05 by alpha by 2, we will see that the value is 2.29. Okay, so value is 2.29. So for the 1524, you can find that the value for 0.05 would be 2.11, but you have to take the reciprocal of that. Then you will see that the upper value is 2.29 and the lower critical value is 0.47. Then you have to find the test statistics value. The test statistic value is really simple. So you can see that you have to take the ratios only. After you take the ratios, you will see that it's since this part is coming from the hypothesis, the null hypothesis, this is 1, and then we basically need to find the proportion of the variances, and we find that this is 1.56. So 1.56 would be in between these two values. So that's why you will see that we fail to reject. That means we cannot reject the null hypothesis. That means they are actually similar, not significantly different. That's what we found. So we saw that how we can perform hypothesis testing if we have two variances and then we are going to do a test where we have critical regions on both sides. But if it is actually the critical region, the rejection region is in one side, that means we are looking at, let's say in the picture where we are looking at, let's draw that. It's drawn, and then it's like that. It's actually more likely steeper. Okay, so at first we are testing whether it's actually the critical region is actually in the upper area or not. So that means this is the critical region. So we are looking at, we should go to the F table and find what would be the value, the critical value for this point. So again we will be using the same, but then again you will see that previously we used level of significance by 2, but in here we are not, because the critical region is only in one side. So the level of significance, you can use what is mentioned in the question or what you want to use. Let's say if you use 0.01, or let's say you can use 0.05, whatever is mentioned. Then you can go back to your table, and then in the table you can again look for 24 V1, and then 15 is for V2, and then over here you can see that the first one is for 0.25, 0.1, 0.05. So we are looking at, this is 0.25, this is 0.5, and this is 0.1. So if the level of significance is 0.5, then you have to use that. If it is sorry, 0.1 versus 0.05. So based on what you use, you can choose them. So in this question, they were using the level of significance. You can see it's mentioned that they are going to use 0.05, I think. So that's why 0.05, so that's why they were using 2.29, and then you can compare it with the F statistics value, and then you can say that whether it's actually falls in the rejection region or in the acceptance region where it falls. So you can see that 1.56 falls in this region. That means we cannot reject the null hypothesis. That means it's actually the variance for the first population is larger than variance for the other population. That means the null hypothesis is rejected. So if it is in the other region, let's actually clear the drawing, and then if we are looking at the opposite area, that means the critical region is here, and then we have to find the critical value for here. So all you need to do is to find the critical value I showed you before, and then you need to use the level of significance. That means this is the area where we have the level of significance, and this is 1 minus alpha. So this is the acceptance region, and this is the rejection region. So we need to find the value. So in the table we found that this is 0.47, since we use the reciprocal, because for the lower region, you have to find the reciprocal, and we find that this is 0.47. but if we compare with 1.56, you can see that it's actually more than that. That means it's actually falls in the acceptance region. That means we cannot reject the null hypothesis. And then for the upper region, we say the opposite, because it's actually 2.29. it's less than that, but it's more than the null hypothesis over here, that the test statistics we found. So based on that, always try to draw them, see where it falls, where is the critical region, and then find the decision based on comparing the critical value and the test statistic value. So that's what we saw today, is that if we want to compare one variance, if we want to test for one variance, then we have to use chi-square test. If we want to test two variances, then ratio of two variances, then we have to use F test. And based on what's our hypothesis, is it one-sided or two-sided, then we have to pick our critical value, and then we have to make a decision whether null hypothesis is rejected or not. That's it for today. Thank you all.